So today I will be presenting our group project construction database system. Our group members are Charisman Sukarnai, me, I am also the group leader, and Levinte Jimmy, Muhammad Azim, Muhammad Aimim. Alright. Firstly, chapter 1 introduction. For introduction, I will be giving Aimim to present.
Assalamualaikum. So now I will talk about our introduction of the group project. We specifically focus on construction job as our topic. The background of this job is that there are constructors who are working for a specific construction company, and these companies always get their job by signing off a deal with their client, and this client might have unique preferences which the construction company need to fulfill, and when they want to fulfill that, they are also have to think about whether their workers can can do the job or up to the task to do the job. So before they can begin the job, they need to keep track of various things. So that's why the management system called construction management system, or we call it as CMS as shorter, comes in. This system ensure operations and ensure systematic construction management, and it can reduce the mistake of the it can reduce the mistake that the workers will make. And this system is also easier to access, and the accuracy of this information is guaranteed to be correct. So the system is mainly simplify the whole resources or data within the construction project, so it can lower the risk of failing, and it can achieve success for the project that the construction companies sign with the client. Okay, that's all from me. Thank you.
Hi, my name is Arun K. Zeming, and I'm about to present the ERD of our construction database system. And first of all, this is our ERD that we made based on the study case given, and there are a few entities that we identify, such as material, storage, construction staff, locker, and tool. And for the first entity, it holds some attributes such as material ID, name, type, quantity, and delivery date. And each material is stored in one and only one storage area, as you can see here. Each material is stored in a specific storage area. And for the storage entity, it holds some attributes such as storage ID, type, size, condition, and maximum capacity. And a storage area can hold one or more material, but may also remain empty. So the relationship between storage and material is one storage may hold none, one, or many materials. And for the next entity, we construction staff, it holds staff ID, name, low, hire date, and assigned storage area. And the relationship between construction staff and material is a single staff can manage multiple materials, and multiple staff member can be assigned to handle the same material. And as we can see here, it's a many-to-many relationship. So we need to create a bridge entity here to handle it. And the attributes related to it are data science, duties, and handling instructions. And a staff member may not be assigned to any material, and a material may not have any assigned staff. So we make optional attributes here. And for the local entity, it holds some attributes such as local ID, location, size, and local status. And each staff is assigned to a unique local, and each local is assigned to only one staff member. While a local may not be assigned to any construction staff. So a local has none or one staff, while a staff have one and only one locker. And for the staff supervision, each staff may supervise one, none, or multiple junior staff, while junior are supervised by a single senior with the attribute size start date and end date. And we decided to implement it inside our contracted staff entity here. Supervisor ID, start date, and end date, and one supervisor can manage one none or many junior, and one junior is managed by a single supervisor. And the last entity here, which is tools, it holds tool ID, tool type, capacity, power source, and status. And the relationship between tools and control staff is a tool may be operated by multiple staff, and multiple staff may operate a single tool. So this is a many-to-many relationship, and we need to create a bridge entity here. And the attribute related to it are assignment date, user duration, and task. And each staff may not be assigned to any tool, and a tool may not have any assigned staff. So we make an optional relationship here. And last of all, one staff are limited to manage a maximum of 15 tools. So we add it here. And that's all from me. Thank you.
Hi, my name is Muhammad Azim bin Madin. So today I'm gonna present about chapter 3 database implementation, which is data definition language DDL statements for create table. So basically for table storage, a numeric column acting as the primary key, ensuring every storage unit has a unique identifier. And for storage type, it's describe the type of storage and cannot be null. So for condition, it's default to either active or not available using the check constraint. So for the max capacity, it store the maximum storage limit and ensure the value is always provided. And next for material table, for material ID, is a primary key for unit identification. So for material name, is ensure no two material have the same name using the unique constraint. And delivery date is a date a column to track when material is arrived or not. So for the last one is a storage ID. Is a foreign key that link each material to a valid storage ID from the storage table. And for the local table, local ID is a primary key that ensure no two locals can have the same ID. And for staff ID is a foreign key that connect to a construction staff table. And for location, local size and local status are marked not null, and this means these fields must always have a value. And for the tool table, tool ID is a unique identifier for each tool acting as the primary key. So for the status, it used to check constraint to allow only active or under maintenance tool only. For tool capacity and power source, it store tool specific detail, ensuring effective tracking. And for the construction staff table, for a staff ID is a unique identifier for each staff member. For staff level, it's default to junior or senior using check constraints. And supervision ID, a self-reference foreign key that tracks hierarchical relationship between staff member. And storage assign link staff to their assigned storage facility using a foreign key. For the construction staff table, It tracks which tools are assigned to which staff members and use a composite primary key of a staff ID and tool ID to ensure unique assignment. And for additional assignment date and usage duration, store the assignment detail. And for the last table, which is construction staff material table, it tracks material assigned to staff member to specific duties, include field light date assigned and duties for tracking assignment. That's all from me. Thank you.
Alright, chapter 3, database implementation. SQL data manipulation language unit operation. I shall be presenting. Right. Firstly, for the ML unit operation, the query retrieve stuff whose hire dates after 11 August 2022. The relational algebra should be like this. Select hire date, the date 8/11/2022, and goes to from construction staff. For the SQL statement, select all from construction staff where hire date is more than 8/11/2022. Following the query where the date is after 11 August 2022. And the result should be like this, where the hire date should be after 11 August 2022. You can see that all of them are after 11 August 2022. Alright, next one. Retrieve lockers that are not in East Wing and West Wing. So this is easy. You just select the table, select table location, not in, this is the symbol for not in, this is the symbol for not in, East Wing and West Wing locker, from locker. The SQL statement should be select all from locker, current location not in East Wing, West Wing, in the bracket. The result should be all of this, where there is not anyone that is in East Wing or West Wing. South, North, Central, South, North, Central, South, North. Should be only this one. This one. Retrieve staffs with names that start with J. The relational algebra should be like this. Select staff name like %J. It should be %. And from construction staff. The SQL statement should be select all from construction staff where staff name like J. The result should be like this, where there is only staff name that is J. Let's start with J. Alright, that's all from me. Alright, thank you for listening to our presentation. That's all, and sorry if we made any mistakes.